Hi guys, today we're going to be talking about section 3.2, which is on logarithmic functions. So what is a logarithmic function? Well, it is already here, log function. It's when you have x equals b to some y power, okay? And we write it as this right here, okay? Y equals log base b of x, okay? That's how we read it. So y equals log base b of x. So what are logs exactly, right? So logs are, log base b is interchangeable, right? It's basically like this, okay? These are the two things it can be. Log base b of x equals y if and only if b to the y power is x. So for example, okay, if we have log base 3 of 27 equals y, then 3 to the y power equals 27. Now, one way that we solve it is by using basically, I call it the loop rule, right? Okay, so if you look here, if we have log base 2, 2 to the third power equals 8, right? We know that 2 to the third power equals 8. So 2 to the third power equals 8. 2 times 2 times 2 equals 8. Makes sense, right? So uh, let's look at some examples, right? So log base 2, so we'll do our loop rule, 2 to the third power equals 8. That's an exponential form. And that's true, right? That makes sense. Okay, let's try another one. Let's see. Log base 4 of 100 or 1 over 256 equals negative 4. So what that says is 4 to the negative 4 power is equal to 1 over 256. Okay, and we know from exponents that negative exponents give us a fraction, and b, it's like 4 to the 4, but 1 over it, right? Okay, so we can check this on a calculator if we want to make sure that this is true, but really they're just asking us to write it in exponential form, okay? All right, so let's look at example 2. So example 2 says to write it in logarithmic form. So now we have to undo our exponential form, right? So let's look at this guy right here. So remember, we said the loop rule looked like this. We said log base x of b equals y, right? So it was like x to the y power equals b. X to the y power equals b. I guess it was written differently. I guess it would be b to the y equals x or whatever. But anyway, we still see the loop rule. So we are going to unpack this one, right? So this guy would be log base. Okay, well, the base of our exponent is 15. So this would be log base 15 of something here equals 3, because we want 15 to the third power equals something. So this would be 3, 3, 7, 5. So you'll see how it basically how it works. So we'd say, okay, well, so if I'm looking at this next one, 4, so it'd be log base 4, okay, of something, which in our case would be 2, equals 1/2, right? And oops, I said 1/2, but I wrote 1/4, okay? So what it means is that if I was going to rewrite this in exponential form, I can check it just with my loop rule, right? I'd say 4 to the 1/2 power equals 2, which is what we want there. So we can always check our answers to make sure they're correct. All right. Okay, so let's look at a third example. Now this one asks us to evaluate a log. Okay, so basically what it's saying is, what is it that makes this true? So what value of x is log base 15, or excuse me, log base 16 of 4 going to be? What is it equal to, right? So the way we evaluate this is we look at it and we say, okay, well, 16 to the what power equals 4? 16 to the what power equals 4? Okay, well, we're going from 16 to 4, which means we're going down. So we know it's probably not going to be a whole number, because like 16 to the 2 is like way bigger than 4, right? And 16 to the 1 is 16. So it's got to be smaller than 1. So another way we could think of this is, how do we go from 16 to 4? I can divide by 4, right? But that's not an exponent. Or I can take the square root, right? So really, it's saying the square root of 16 equals 4. So how would we write x as a square root? Well, it's actually going to be 16 to the 1/2 power is equal to 4. So what is the value of x? It's 1/2. So what is log base? Log base 16 of 4 is actually going to be 1/2. Okay? All right, very good.